1.6. Our goal here is to solve linear inequalities. So we'll start off with some simple inequalities on a number line. It says graph x is less than 2. So you draw a number line. I like to put 0 on there. You don't have to. 2 should be to the right of 0. And you should remember from previous classes that the less than symbol means we're going to use an open dot instead of a closed dot. Closed dot means we include 2. Open dot means we get close to 2 but don't touch it. Less than 2 means we're going to shade off in the left-hand direction. Done. A similar process is going to go into graphing x is greater than or equal to -1. This time we see the greater than, that means shade to the right, and the or equal to means we fill in that dot. Like so. Compound inequalities are a little bit more involved. We want x to be between -1 and 2 is what this next one says. So we draw our number line and put in our points just like we normally would. Both of them open dots. And since we want that x between -1 and 2, we shade in between. And we're done. When we see that or, it's a little bit different. Still start with our points. This time we want x bigger than 1. That means go to the right. Or less than or equal to -2. And go to the left. If you accidentally shade on the outside, you should be shading on the inside. You're wrong. The way I think this is easiest for me to remember, when I'm doing an or problem, kind of looks like if you're in a canoe, the oar is on a boat. They're sticking out to the side, you put them in the water using the oar. It's a little gimmick to remember when you shade inside or outside if you have trouble. At this point, you can pause the video and try the guided practice on your own, or you can do those later. Next, we have some rules for inequalities. They're pretty much the same rules that we had for equations. We already saw this one for equations, adding to both sides. We saw this one, subtracting from both sides. We saw multiplying on both sides. Notice it says positive. I'll talk about that in a second. We see dividing on both sides. The only thing new is if we multiply or divide on both sides by a negative, you have to flip the inequality. Notice it goes from less than to greater than. If you forget to do that, your inequality is backwards, which makes it as wrong as can be. So be careful. Example 3, you have $50 to spend at the county fair. You have to pay $20 for admission. You want to play a game that costs $1.50 each. So we're going to find out the possible number of times we can play the game. So we set up an inequality. We know we have $50 max. So whatever we do has to be less than $50. I made a mistake. Whatever we do has to be less than $50. We'd set that up like this. So we know we're paying $20 to get in. That limits how many games we could play. And we also need a variable for number of games. So maybe we call that X, number of games played. We know those games cost $1.50 each. So we say $1.50 times number of games played. At this point, we just have to solve the inequality. Technical difficulties. Solving for x, we end up seeing that x is going to be an inequality this time, but not an equation. So we'll subtract the 20 from both sides first. Then we divide both sides by 1.5. And we get x is less than or equal to 20. That means we can play 20 or less rides. You don't have to play exactly 20. We have $50 to spend. We don't have to spend the whole thing on rides. but we can play 20 games or less. Next, it says we're going to solve an inequality with a variable on both sides. I like to keep the variable on the left. It helps me figure out which way to make the arrow point. So I'm going to subtract 7x from both sides first. You could subtract 5x from both sides first, but then your variable is going to be on the right. I think that opens you up to more mistakes. The red flag warning right here. Before I divide by -2, I need to remember I'm actually dividing by a negative. So I don't write greater than, I write less than 3. If you stop here, you made a mistake. If you look at the directions, it does say to graph the solution. So make sure you know. I'll be looking for the open circle and the direction. At this point, you can pause the video and try these on your own, or you can wait until later. Now we're going to solve an AND compound inequality. These are a little tricky because there's not 2 sides to the inequality or equation like we're used to. There's 3 sides. So we see that 6x minus 10, and we want to get rid of the 10. Yes, we add 10, not to both sides, but to all 3 sides. And there's 3 pieces to an equation or an inequality. You have to do the same thing to all 3 pieces. Other than that, it's the same thing we're used to. Divide not both sides by 6. Divide all 3 pieces by 6. And we've got the inequality. Again, if we stop here, we've got a problem. You've got to draw the graph. When I'm grading, again, I'll be looking for the open dot, the closed dot, and the correct shading. Or inequalities are a little different. We basically treat these as 2 separate problems. We're going to solve both of them, and then we'll do our graph. Notice once we solve these, we still got to keep in mind that this is an OR problem. So when we draw our graph, I want numbers less than 2 or equal, and less than or greater than or equal to 6. So I see the ORs. I know I did it right. I'll be looking for the dots and the shading. Last example. A monitor lizard has a temperature that ranges from 18 to 34 degrees Celsius. So I might draw something like this. I know my temperature in Celsius is from 18 to 34 degrees. It says write the range of temperatures as a compound inequality. That's actually what I just did. Compound inequality is where you have more than one inequality symbol. Then we want to write an equation or an inequality giving the temperature range in degrees Fahrenheit. So we have to know how to convert from Celsius to Fahrenheit. That's not something I expect you to have memorized, but if you go back a couple lessons, it's one of the formulas I gave you. I'll give it again here. That's how you convert from Celsius to Fahrenheit. Should have put or equal to on both of those also, because we could be 18 degrees Celsius exactly. Now we have to go through and solve. A couple of tips when you're solving this on your own. You see that 5/9 to get rid of it, multiply everything by 9 over 5. So maybe a way to see that would be to multiply everything by 9 over 5. That's going to give you some decimals, but that's okay. You have 32.4, f minus 32, and 61.2. Last step, we want to get that 32 gone, so we add 32 to all 3 pieces, and we'll get our final answer. We now have a range of the monitor lizard's temperature in degrees Fahrenheit. It doesn't tell us to graph this time, so we don't have to. At this point, you can pause the video and try these on your own, or you can do that later.